This question says, Bootleg Jimmy wants to find the height of a flagpole on his pirate ship. He measures the slope angle of 27 degrees. So that's right here. This is 27 degrees. His eye height is 4 feet above the floor, so this is 4, and this would also be 4. And he says he is standing 35 feet from the flagpole. So this is 35. And since this is a rectangle, this is also 35. They want to know how tall is the flagpole. So first I'm going to find this part of this triangle. And I'm going to redraw it right here. So this was X. Here's my right angle. This is 35. And the angle in here is 27. Hopefully you recognize that we need to use tangent. So I'm going to use tangent and do the tangent of 27 over 1 is x over 35. Cross multiply. Now I'll find that for you real quickly. So it's about 18.9. The only problem is that's only this part. So if we want the whole thing, we need to add 4 more. So the final answer is about 22.9 feet. That's how tall his flagpole would be. Don't forget to add the extra eye height on. In question 18, it says we have an equilateral triangle, so I drew that below. Hopefully you know an equilateral means all the sides are equal and all the angles are 60. It says the height of the equilateral triangle, which I'm going to draw right here, right in the middle. This height is 10 square root of 3. Well, if you see this triangle, just half of it, this would be 60. Half of 60 degrees at the top is 30. This is 10 square root of 3. And again, this is one of our special right triangles. So the other side would be 10. So this is 10 and this is 10. The hypotenuse is double, which hopefully makes sense. The other side would be double, and they want the perimeter, so it's just going to be 20 times 3, which is 60 for the perimeter. Question 19 is similar to the one we just did. They tell us again it's an equilateral triangle, so I drew one that was 60, 60, 60. And equilateral means all the sides are the same. Only this time it says the side is 8, and they want us to find the height. So I'm going to split this down the middle, and I'm going to break up my triangle to the side so I can see it. So this is 60 degrees. The top would be 30. They told us that the side is 8, and hopefully you would see that these would then have to be 4 and 4, so this is 4. And opposite the 60, again, has the same number 4, but it has a square root of 3 attached. And that would be our height of this triangle. In question 20, it says a right triangle's hypotenuse has length of 7. So I drew a triangle. This is the hypotenuse. It says one leg is 4, and they want us to find the other leg. So we just have to do the Pythagorean theorem. A squared plus b squared is c squared. And in this case, the hypotenuse is always the c value. I'll do that for you real quickly. So in number 20, I just did the Pythagorean theorem. In the end, I got the square root of 33. Or you can plug that into the calculator. It's about 5.7. So if I have this information now, I could find the area and the perimeter of that triangle. In question 21, they ask us to solve for x. So whenever you have one side and one angle, you have to use SOHCAHTOA. Opposite the 59 is the 12, and x is adjacent, so we have to do tangent. So I'm just going to set up tangent of 59 over 1. Is 12 over x, and then to solve we just cross multiply. And in this one you don't even have to use the calculator. I get x times the tangent of 59 is equal to 12, and then we have to divide by tangent of 59. And that happens to be choice A. That's the answer. In question number 22, it says refer to the drawing from question 21 above and find all that are true. And this says, is the sine of A equal to the sine of B? Well, hopefully you realize that's not possible, because the sine of A would be the opposite, which is 7.2 over the hypotenuse, and sine of B would be 12 over something. So these two are not the same. The next one says the cosine of B. Well, the cosine of B would be 7.2, and the sine of B would start with a 12 when I'm just doing SOHCAHTOA. So that can't be true. If you look at the diagrams, it is true that the cosine of A and the sine of B are the same because you're going from different angles, and you end up getting the same ratio. Tangent of A and tangent of B are not the same. If the cosine of A and sine of B are the same, then the cosine of B and the sine of A are the same. And the last one, well, F is the exact same thing as E, so all three of those are true. You could also check them with your calculator.